So in this video, we are going to solve this question using the scalar approach. Okay, so we are going to solve this question using the scalar approach, and the scalar approach says that moment equals what? Force times the perpendicular distance d. Okay, so we are going to use this formula to solve this question this time around. Okay, so let me redraw the system. So I redraw the system here. So let's say I have this to be my x. Okay, I have this here, and then I know this distance here. Okay, and then I know this distance also. Okay, so let's say this is the force. Okay, so let me show the line of action of the force. So let's say that one will be somewhere here. Okay, so this is the line of action of the force. So since it is over there, let me extend this line. Okay, so that's the line of action of the force. So the force is acting on this line. So I have my y here, I have my x here. Let's make this angle theta. Okay, so this is point B here. Okay, so this is point B. Okay, so this D here is the perpendicular distance from the point B here to the line of action for the force. So any perpendicular distance from this point B here to the line of action of the force. So let's look at that perpendicular distance. It has to make an angle of 90 degrees with the line of action of the force. So from here, let me get this line. So let me make it straight. So I have something like this. Okay, so you see that you have 90 degrees here. Okay, so that will be our D. That will be our D. Okay, so this is our D. So this D that we are looking for. When you are able to get this D, you will multiply by this 15 Newton force. So how are you going to get this D? You know that from this side to this side is what? 350. Okay, so that's 350. So let me make this 350. So let's convert this into meters. So 350 millimeters will be equal to 350 times 10 to the power minus 3, and this will give me 0.35, and then 200 millimeters will also be 200 times 10 to the power minus 3. This will also give me 0.2 meters. So I'll put 0.35 here, and then 0.2 here. Here will also be 0.2. Okay, so now we want this D. Okay, so for us to be able to calculate for this D, let's do some analysis here. Let's look at this. So you know that from this side to this side is 0.35. So what about this side? How are you going to get that length? Because you know, when you get this length, you can subtract this 0.2 from this length to get just this side here. Okay, so how are you going to do that? So let me make the whole of this place from here. Let me see. Okay, from this length here. Okay, so from here to here, let me name it A. Okay, so let me name this side A, and then the small distance inside here, that's from this side to this side. Okay, let me name it B. Okay, so now you know that A is the longest side, and then B is the smallest one. Okay, and then B is the smallest one. So you want to find B, and before you can find B, you must find A, and when you get A, you subtract the 0.2 from A, then you get B. So you see that B equals what? A minus what? 0.2. So now what our main focus will be on is what? This A. How are you going to get A? So let's look at this. So when you look at this figure here, okay, you can see that we have this angle here, and then we have this 0.35 here, and this 0.35 is opposite to the angle. So when this is opposite to the angle, if you're able to get this angle, you'll be able to get this point A here. So how are you going to get this angle? Look at this 3 and then 4 value here. This 3 and then 4 value here is representing something like this. So here is theta, here is 4, and then here is 3. Okay, so this whole figure that we have here looks like this. Okay, so the angle that this figure will make with the horizontal is that same angle that will be here. So these values were given to us to help us find this angle. So now let's find the angle. So this angle here, okay, you see this 3 is opposite to this angle. So if I want to find this angle, I can say tan theta because opposite over adjacent, so that will be 3 over 4. So theta will be equal to the tan inverse of 3 over 4. This will give me 36.87. Okay, let me leave it this way. Okay, so that will be 36.87 degrees. So now I know the value of what? Theta. Okay, so theta is what? 36.87. Okay, so now since you know the value of theta, you can find A. Okay, because you know that theta here is what? 36.8. So now you can see that this 0.35 is opposite here, and this is also what? Adjacent to the angle. So we need this A here. So you can use tan. So you can see that the tan of the angle 36.87 equals the opposite, which is 0.35 over adjacent, which is A. And you want this A here. So this A will come to this side. So A will be equal to 0.35 over the tan of 36.8 36.87. So that should give me the value of what? My A. Okay, so that will be 0.35 divided by tan of 36.87. So this gives me 0.4667. Okay, so this is what I have for A. Okay, so let me clean all this and then write down my A. So I have A to be equal to 0.4667 meters. Okay, so that's my A, and I know that B equals what? A minus 0.2. So when you do this, you'll be able to know this B here. So that should be equal to 0.4667 minus what? 0.2. So that gives me the value for B. So this will give me 0.2667 meters. So that's the value for this B here. Okay, so that's the value for this B here. So what you are going to do is that now you will need this system here. Okay, you need this system here, this small triangle here. So when you get this small triangle, then you'll be able to find what? D. And when you get D, you multiply by this 15 Newton force here to get our moment. So now you know B, which is this small length here. So now let's redraw the system. So I'll draw the system again. So I have something like this. And then this is over here. Okay, this is over here like this. And then okay, so now extend this. Okay, so this is the 90 degrees here. So this side here will be the D. So this side here will be the D, and then this side will be theta, which is what? 36.87. Okay, let's manage that. I know I've really squeezed it. So I have here, and then here is my B, which is what? 0.2667. So now you need this D. Okay, so let's go ahead. So when you look at this side will be the hypotenuse, this will be my opposite, and then this will be what? My adjacent. Okay, so I now need this D. So this is opposite, this is what? Hypotenuse. Okay, so you can use sine. So you can say sine 36.87 because the opposite, which is D, over the hypotenuse, which is what? 0.2667. So therefore D will be equal to 0.2667 times sine of 36.87. So this is what I have here. So let's get the value for D. So I have D to be equal to 0.159999 meters. So now that's the value for my D. Now that we have D, we can find the moment. Okay, so we said the moment equals on the first times on the perpendicular distance, and that perpendicular distance is this D value that I have found here. So let's go and multiply this D value here by the 15 Newton force, and let's see what you get. Okay, so moment equals the force, which is 15 times the perpendicular distance, which is what? 0.1599. Okay, so that will be equal to, okay, so that gives me 2.3999 Newton meter, and I can run this to 2.4 Newton meter. So that will be our moment. Okay, so that will be our moment. So that's the answer for this question also.